Welcome to the webinar on securing applications in the hybrid cloud with automated compliance. My name is Russ Schaefer from Cloud Raxak. This webinar is presented by IBM, Intel, and Cloud Raxak. Cloud Raxak is a security compliance company based in Los Gatos, California. I'm sure you've heard of IBM and Intel. So let me introduce you to our distinguished speakers so we can start the presentation. First, we have Heather Hinton, a PhD from IBM and distinguished engineer. She's the CTO of Security and Compliance Architecture and Innovation. We have Sesh Murthy, a PhD, Cloud Raxak co-founder and SVP and CTO, former IBMer. And Raghuram Yeluri, who's a principal engineer and lead security solutions architect from Intel. Before we get started, we're going to do a quick audience poll. You'll be receiving that in a minute. But let me go over the rest of the agenda before you get that. Cloud security trends. We'll take you through what's going on in public and private clouds. Talk about solutions available in hybrid cloud security, including some focused use cases on life sciences and financial services. Then we'll go into a deeper discussion on automated and simplified security compliance. Talk detail about a retail case study. Then talk about assured compliance, what that means and how we use a harbor root of trust. Go into a demo to show you how it all works, and then go into a Q&A. So let me go ahead and pose the votes so we can get a quick audience poll, and then I'll hand the presentation over to Heather in a minute. So go ahead and place your vote on the first question around, are you currently using a private or public cloud? All right, any other votes for that before we pose our second question around which vendor you're using? So I'll go ahead and close the voting on that. All right, so you give us an idea of who you're currently using for your public or private cloud solutions. Again, we'll use this information to kind of guide our discussion so we present material that's relevant to everybody that's on the webinar today. All right, looks like we're getting quite a few votes on that one. Maybe 4 more minutes before we get to our third question. Then we'll have one more left, and we'll get started with the presentation. Okay. Next question, how do you currently do security compliance? Manual, internal tool, external tool, or other? All right. All right, last one. Are you satisfied with your current security compliance solution on the public cloud? Great. All right, so let's go ahead and move on with the presentation. We'll go over those results a little bit later. So I'm going to go ahead and hand the presentation over to Heather Hinton from IBM to start with cloud security trends. Presentation is yours, Heather. Thanks.
Excellent. Thank you very much, Russ, and to all the attendees, good morning, good afternoon, and good evening. So I wanted to talk a little bit about cloud trends and in particular hybrid cloud. The numbers that we saw in the poll looked like it was ranging between 35 and 40% of the attendees are using hybrid cloud. That certainly meshes with what I see when I go and talk to clients from small to large. They all have or are investigating a hybrid cloud strategy, and they are all universally using some form of something as a service, the software as a service being predominant, infrastructure as a service, and platform as a service. When I go and talk to clients, what we work through, what I spend a lot of time working through, are the roles and responsibilities for securing a cloud-deployed workload. In particular, the differences between what the cloud provider is responsible for and what the customer is responsible for. We spend a lot of time working through understanding what the cloud provider does and really coming to terms with the I guess the penultimate quote here from Jay Heiser, which is that you will have a security breach when you're on cloud, and it will be your fault. It will not be the cloud provider's fault. That's also been stated by, and so Jay is from Gartner. We've also heard similar things from companies such as Forrester. So it's relatively accepted that people need help when they move to cloud. They need to work through that shared security, the shared responsibility model.
Hey, Heather, looks like your
Yes.
audio is having some issues here, so let's hold on just a quick second. Oh, it's back again. Okay, good.
Okay.
All right, keep going.
All right, super. Thank you. And just so that you know, I've moved to the next slide. When we are working with clients on how do we deal with hybrid cloud, there's a lot of concern over how do I mix the different models that are available to me. What do I keep in traditional IT? What do I put into an on-premise cloud? So how do I get that on-premise cloud? Am I going to go with OpenStack? Do I set up an off-premise cloud? Do I use somebody else's infrastructure but then bring my own virtual cloud or dedicated private cloud to that environment? Or am I just going to bite the bullet and use that shared off-premise cloud that seems to be the focus of so many of the analyst reports out there? When we go through these conversations, what we're looking at is what kind of data are you bringing to the cloud? What types of models do you have? Where does the data have to stay on-premise for performance reasons? Does it have to stay on-premise for regulatory reasons? How persistent or transient is this application that you're building going to be? Is it something that is best suited to a highly transient nature that makes sense in a public cloud environment? How do I manage this environment? How do I extend all of the policies and procedures and tools that I have from my existing traditional IT environment and bring them into my hybrid cloud or my off-premise cloud? How do I make sure that I have the same level of security and compliance for this new world in which I'm working? Because what I need to do as a client or as somebody who's bringing a workload into the cloud, I need to make sure that I have a consistent security posture. My security posture in traditional IT should be the same as what I have and what I'm able to put into place in cloud, no matter what kind of cloud it is that I'm working with. And once I've done that, I'm able to have a conversation that is now based not on what is the right cloud model based on security, but what is the right cloud model based on my workload needs and my expectations there. So that gets into details about hybrid cloud security, which is something that I spend my time working with clients for. And it's what we work with is how do we clearly define what the cloud provider is responsible for and what the customer or the client is responsible for. And so with the cloud providers, they're responsible for the physical compute the storage, the facilities, by the way, that host all of that environment, the network that I'm going to be using to bring my data and my workload in and out of the cloud to access that, virtualization if I'm using a virtualized cloud, right? Remember, I have the option for doing virtualized servers in the cloud or physical servers in the cloud. How am I going to manage those as the cloud provider? And then what, as a cloud provider, do I provide to my clients to actually manage this environment, to order servers, to provision storage, to enable my users to be able to go and use this cloud environment. And the reason that cloud works is because cloud providers have figured out how to do this in an automated way and in a way that's transparent. And by transparent, I mean that when the client asks for something to happen, it happens, and then the client gets complete visibility. They get evidence into what I've done. I've asked for this type of server. I get evidence that this is the server that I've asked for. I've asked for 4 cores. My evidence tells me that I've got 4 cores. I asked for it to be provisioned in Dallas. It was provisioned in Dallas. This is a very clear set of responsibilities that I can work through and be comfortable with. And now what I have to pay attention to is when I've got my servers, my cloud servers, how are they configured? And this is where the client, working on their own or working with a partner such as Cloud Raxak, assumes responsibility. How do I configure firewalls? Do I have appliance firewalls? Do I have operating system-based firewalls, software firewalls, IP tables? How do I configure my operating system? How do I lock it down so that it's got a tech spec sort of assigned to it? What are the required configuration items for my operating system, my network, and my application to make this something that is worthy of hosting a particular workflow? Just as automation is a critical part of how the cloud provider provides the infrastructure to the client, automation is going to be the key to how I can actually convince my risk management teams, my auditors, my business process owners that hosting a particular workload on the cloud is the right way to do it. So in particular, I work with SoftLayer and with IBM clouds, and what we have here with IBM and with our SoftLayer cloud is the additional advantage of the Intel TXT-enabled physical servers. So now what I get to do is I get to take the automation that comes from my infrastructure management. I get to take the visibility that comes from the information about what I've requested and is that what I actually got, and then I get to include with that the additional data that comes from using Intel TXT and the Intel SIT functionality that I think Raghu is going to be talking about a little bit later in this presentation. When I couple this together with the automation that comes from Cloud Raxak, being able to tie all of the configuration that's happening for my infrastructure together with my servers, I've got a complete boot to runtime security and compliance statement that I can make about my environment. So I talked a little, so I'm now on slide 9. I apologize, I haven't been telling you the slide numbers. What I get with, to repeat what I said, let's talk about this in the context of workload geolocation is what we call it. So let's say that I require that this workload only run in the US as an example. So I've got some sort of processing that cannot leave the United States. What I do with the SoftLayer model is I request that whatever it is that I'm provisioning be located in the US, and in fact I'll pick the data center that it has to go into. And so I have SoftLayer providing me with that choice and providing me evidence that I've in fact satisfied that choice. For those people that want an additional level of assurance, what I now have with Intel TXT is the ability for the TXT processing to say, yes, this workload can only be deployed in Dallas, and I guarantee that that has in fact been done, and I get the visibility that this has actually happened through TXT. And now Raxak can go and enforce this by making sure that what SoftLayer says and what Intel says both match, and they are in fact what I have required me to have in place. So I've got an even stronger statement on the compliance that I've got for my infrastructure that is now hosting my workload. So in the context of how we use this with different client examples, there's two in particular that we wanted to talk about. One was life sciences. And so if I'm in the life sciences and I'm governed, for example, by the Food and Drug Administration, regardless of whether I sit in the U.S. or not, if I'm dealing with drugs or clinical trials, I'm governed by the FDA. And I have to follow what we call general good practice. And so it's GXP because X can actually stand for lots of different letters. But in general, GXP compliance means that I've got good practices in place and I've put in additional evidence on what goes on with my environment. I actually have proof that if I requested a server that has 4 cores, that I get a server that has 4 cores. If I've requested a server that has Windows Server operating system on it, that is in fact what I got. That if I requested it be patched in a certain way, that is in fact what I got. And what I do now is I take the evidence that comes from SoftLayer, I take the evidence that comes from Intel, and I take the evidence that comes from Raxak, and I put all of this together so that I have documented evidence that everything is done as it was requested and it's done repeatedly, so that every time I ask for a particular server to look like something, it will in fact look like that. We call these procedures qualification. So I talk about qualifying a server, that what I requested is in fact what I got. This sits on, in the case of SoftLayer, a validated infrastructure, and in fact I am currently in the process of doing a validation audit for our data centers. And so we are ensuring that the standard operating procedures that we have in place are those that are necessary to support GXP compliance and in fact all regulated workloads, to ensure that what we're doing is that the standard operating procedures define everything that needs to happen for the physical facilities, the environmental facilities, the server management, and that they are being managed in a way that is consistent with GXP compliance. When I put all of this together, what I now have is an environment in which I have all of the levels of proof that are required, not the evidence as proof, that says this infrastructure that I'm going to be hosting and this workload that I'm going to be hosting in the cloud meets all of the requirements that are necessary to host a drug clinical trial, or to keep, for example, protected health information or financially regulated data or whatever. So what I have with a GXP compliant environment is one that is managed to the highest standards that will support me moving these regulated workloads into the cloud environment, and further one that is, because of its compliance and because of its qualification and validation, is one that I can split. So I can keep part of my, if I'm doing a drug trial, I can keep all of the drug-related data on-premise in my traditional IT environment, but I can extend the analytics that are being done on that data, for example, into my GXP compliant cloud, which would be a dedicated off-premise GXP compliant cloud environment. So I'm enabling, through this type of compliance, the type of hybrid workload that we are being asked for in these highly regulated environments. So likewise, with financial services, I have to meet these types of requirements, but I don't have the same audit requirements on me. But my financial services clients require the same thing. Even though they're running DevOps, internal workloads, storage, or archive or backup or retention type of scenarios, whether they are using the cloud to extend some sort of an application to a partner, or whether they're making something available to a client, new banking web apps, for example, to try and attract new customers, or I'm dealing with data collection from my customers. All of these things are what our financial clients want to bring to the cloud. Depending on what they want to do, Some of it will be hybrid, where it will be split with data staying in traditional IT, just as it is for GXP compliant environments. Some of it will be something that goes into a shared, completely off-premise public cloud, for example, offerings to come and sign up for a new service at the bank might be something that would be very short-lived and transient and would be suited for the cloud. In all cases, what I have to do for these clients is I've got to work with their internal IT security, with their risk assessment groups, to make sure that they are comfortable that this environment is one that is managed to standards that comply with their internal standards and that will provide minimal risk to the bank for hosting in this type of environment. And so we do this through the automation and the evidence that we have that demonstrates how we're going to go and manage the infrastructure that we provide to the cloud. And then what we do from there is we go into the conversations on, I'm comfortable with how I've got this infrastructure managed. Now what I need to understand is, how do I manage my workload? How do I ensure that my workload is properly protected if it's going to be internet facing? How do I ensure that my operating system is properly patched? How do I ensure that all of the services that I want on my workstations, on my servers are available or not available, as the case may be? How do I make sure that Telnet has been turned off and stays turned off on all of my internet-facing machines? And this is something that we need to start working with partners such as Cloud Raxak to do, because what I get with Raxak is, regardless of the types of compliance requirements, the bar is always high. The bar always requires that I have a high level of security, a high level of compliance, and the evidence to demonstrate that. And that's where working with Cloud Raxak has been very beneficial, because what it lets me do is tie all of the evidence that I get from the cloud infrastructure with the configuration and evidence for the workload to go and provide that additional level of confidence on the overall cloud environment that I've got. So I've talked a lot about Raxak, but we haven't really introduced it. So at this point, I'm going to turn over to Sesh Murthy so that Sesh can tell us more about Raxak, and then start also talking about Raxak with Intel TXT. So Sesh.
Thank you, Heather, for clearly describing how customers run their applications on a combination of traditional IT, private clouds, and public clouds. In fact, we've seen many customers, especially in financial, pushing to be on multiple public clouds, not just one. You described how security is a shared responsibility and how customers need to automate their security compliance and get a consistent security profile posture across their different kinds of IT infrastructure. Next, I'll show you how Cloud Raxak automates and simplifies security compliance on both public and private clouds from boot to end of life. I'll show you an example with a retailer. When I'm done with that, I'll show how we can extend what we do in a compliance to a hardware root of trust working with Intel CIT. And this works very well on software and on private clouds. So Heather talked about how cloud security is a shared responsibility. She talked about what needs to be done by the customer and by the cloud provider. Let's explore what this means a little further. In the public cloud, in the light blue on the top right of my chart, there are a large number of parameters in the IaaS layer that need to be set correctly for the infrastructure to be secure, for the assets to be secure. These range from settings on the OS firewalls to settings on the operating systems, etc. We have worked with financial customers where they have over 1,000 settings that need to be set correctly and then checked to see if they're compliant. As Heather mentioned, customers sometimes make the mistake of thinking that the cloud provider is responsible for configuring their infrastructure correctly. Cloud Raxak has published a report on its website that shows that if you get a brand new VM on many of the public clouds, over 50% of these parameters are set incorrectly with respect to the security guidance given by DISA. It's actually the customer's responsibility to set these configurations and then to know what to set and then to set it correctly. Secondly, even if customers knew exactly how to set their configuration parameters, we find that manual security compliance is slow and error prone. We find that these errors can result in security exposures. So fortunately, most of these configuration parameters in the cloud can be checked and set automatically. On the right, we show how we do this with Raxak Protect. Raxak Protect applies a security profile that's in red to the compute assets on the right-hand side and make sure that the actual state of the assets is compliant with the desired state. So let me tell you a little bit more about how the Raxak Protect platform automates and simplifies security compliance. I'll talk about 4 key things. So firstly, we talked about the security profile on the previous chart. The customer needs to describe the desired state of their compute assets in a security profile. Cloud Raxak provides standard off-the-shelf security profiles that include the DISA mission-critical classified STIGs, and we have also created profiles that include industry standards like HIPAA, FFIEC, PCI, FISMA, etc. This simplifies the security compliance process because we provide a clear starting point with a recommendation on how to set up the security compliance. Next, Raxak Protect monitors the actual state of the assets with respect to the desired state described in the profile on a near continual basis. It stores any findings in an immutable database and creates reports that are audit ready. If there are any findings, this can be auto-remediated. I'll talk about this next. And it's possible to create a ticket so that the remediation can be done under change control. I'll show you how this works with a demo. Raxak Protect is integrated with service catalogs to simplify compliance, to provide one-touch compliance. And we are also integrated with DevOps tools to make it easy for customers to set up a security profile that works all the way from development to production without having to spend development expense on that. Lastly, Raxak Protect is a highly scalable architecture where agentless, I'll talk more about that soon. It's API driven. It's available as a software as a service or as an appliance on-prem, and it works on both virtual or bare metal servers. So let me spend a few minutes talking about the architecture of Raxak Protect. The dotted blue line in the center is the Raxak Protect service or the appliance. The API call to Raxak Protect has 3 key parameters: the security profile that's applied by Raxak Protect, the target assets, and the frequency with which this compliance checking and remediation is done. Let me talk about these 3 aspects first. So the security profile that's applied by the policy engine is to the left top of the dotted blue box. And we implement the DISA mission critical classified security technical implementation guidelines in their entirety. We have also implemented all the key industry standards, including PCI, FFIEC, FISMA, etc., that are essentially subsets of the desired STIGs. This makes it easy for the customers to start from the profile, customize it to what they actually need. As I said earlier, the profile describes the desired state. If the compliance check reveals a discrepancy between the actual and the desired state, we log this in the compliance database. Based on this, we create audit-ready reports. All activities that are performed are stored in an immutable transaction log. I will take you through this in the demo where you can see, for example, how we call the Intel CIT technology and get the attestation from there. And these can be reviewed later. An important feature is that these checks are performed without placing an agent on the server or the virtual machine. We come in externally, perform the check, collect the results, and leave the machine. We avoid agents for security reasons and for performance considerations. As you know, they interfere with the workloads running on top. Of course, this means that we are dependent on the machine booting correctly for our results to be accurate, and I'll talk about that further. Secondly, the target assets can lie both on the public and the private cloud. So as I mentioned earlier, we're seeing customers who are using multiple public clouds. We work with all the key public clouds, including SoftLayer, Azure, Rackspace, and Amazon, and with private clouds. On SoftLayer and on private clouds, we're able to access the Intel CIT technology to provide assured compliance. And this is an added feature that I'll talk about later in the second half of the presentation. Lastly, the continuous compliance engine repeats these checks on a continual basis, and so you are able to get continuous compliance from boot to end of life, and you're able to get a consistent security posture across multiple public clouds and private clouds and your traditional IT. We have integrated Raxak Protect with service catalogs to be able to simplify the application of security compliance. I'll show you this with the OpenStack demo that we're doing later. We have integrated it with the DevOps tools to be able to provide security compliance that does not slow down DevOps. So let me next talk about the critical issue, which is what are security profiles and how do you choose the security profile that you need for your particular application. So depending upon your industry and the geography that you're operating in, you have a set of security requirements from general industry standards, for example, ISO 27001, the industry-specific standards like PCI, GXP, etc. Heather talked about GXP. Government regulations like HIPAA, FFIEC, and conformance with international national laws, for example, EU data privacy laws. What we have found is that these set of requirements that come from these industry and government regulations is a subset of the security technical implementation guides that are provided by the Defense Information Systems Agency. These are publicly available and are applicable to workloads as a best practice. What we have also done is to take the DISA guidelines and to create subsets to create the profiles, if I may, for finance, that's FFIEC, HIPAA, PCI, FISMA, etc. So let me give you an example of how this is done. So one of the key regulations that our customers ask us for help with is PCI. The PCI document is extensive and it's got a lot of English descriptions. On the left-hand side is a description of 2.2.A, which shows how the organization system configuration standards need to be set for hardening. On the right, we show how we translate this particular English stanza into the actual security technical implementation guidelines that are provided by NIST. We parameterize it to exactly match what PCI says, and there are 4 rules that we mention out there. So in this fashion, we're able to create an actionable set of rules that are applied in the profile to the compute assets. Next, I'll show you how we applied this PCI profile to a leading retailer, Life and Home. Life and Home is a US-based retailer that has grown rapidly. They found that security compliance was costly and time-consuming and was slowing down DevOps. They wish to maintain their security compliance while developing in an agile fashion to create an innovative shopping experience. So a little bit about the environment. The environment consists of both development and production servers, which they hermetically seal from each other for security reasons, and that are hosted on bare metal regions for security. The Cloud Raxak provides security compliance for Life and Home using an on-premise appliance. We first conducted an audit of the security compliance settings of Life and Home. I must stress that Life and Home was extremely security conscious to begin with. This is a company that prides itself on security. In spite of this, we found a number of parameters that were set incorrectly, creating potential security exposures. These included some parameters that were set incorrectly to start with, and others that drifted over time. We have seen this these kind of findings in every single instance where we have done a security audit on the customer. Raxak Protect helped Life and Home to remediate these findings. We have now created a PCI profile that is applied continuously to the development and the production environments that provides continuous compliance all the way from development to production without slowing down DevOps. And Life and Home is happy because they can continue to develop in an agile fashion and provide an innovative shopping experience. Okay, so I finished telling you how Raxak Protect provides the continuous compliance from boot to end of life and for both public and private clouds. Next, I will talk about an industry-first capability that Raxak Protect provides by leveraging the Intel CIT technology. So let me tell you a little bit more about what we do out here. This is a repeat of the chart that Heather showed around how Raxak Protect can provide private cloud assured compliance. Raxak Protect leverages the Intel CIT technology that's present in private clouds and in soft layer bare metal to verify from a hardware root of trust that the server has booted correctly and that the kernel on this bare metal machine has not been tampered with. Next, coming in from the outside, it verifies that the cloud management software, it verifies that the operating system is configured correctly. Then it verifies that the cloud management software has not been tampered with and it is configured correctly. Lastly, it ensures that any guest VMs on top have the correct security compliance applied. So in a private cloud or on soft layer where you are getting bare metal, this allows you to go all the way from the bare metal machines, check the OS, check the cloud management software, and check the guest VMs. So all from a hardware root of trust and from boot to runtime. So next, Raghuram Yeluri from Intel will describe the Intel CIT technology. After that, I'll show you a demonstration of how we use that technology to provide assured compliance. So Raghu, as we introduced him earlier, is the principal engineer and the lead security solutions architect at the Data Center and Cloud Products Group at Intel. He has a focus on virtualization and cloud security. Over to you, Raghu.
Right. Thanks, Sesh. Like Heather and Sesh have talked about, Intel's focus in clouds is we believe that security of private clouds and public clouds requires infrastructure integrity. And that's what Intel has been focusing on for quite some time. And in establishing and propagating a new security control, what we call platform trust. Okay, and this platform trust is rooted in hardware, and it can provide visibility to tenants on the integrity assurance of the platforms on which they are running their workloads. It can be used for monitoring, and you can use it to control where your workloads can and cannot run. If there are sensitive workloads, like a lot of the compliance work that Heather and Sesh talked about, you can control through orchestration and indicate that these workloads will only run on servers and platforms which have provided assurance of integrity. Okay, there are two technologies from Intel that make this happen. One of them is a hardware capability called TXT, Trusted Execution Technology. And at a very simplistic way, TXT gives you a way to ensure that everything in the boot process is measured, what the industry calls the measured boot model. And then it's complemented by a technology called Cloud Integrity Technology, which gives you a proof of integrity assurance for your compute, network, and storage platforms. It provides this chain of trust all the way from the time you boot the server up through the firmware, through the operating system, through the hypervisor, into the guest environments, and whether their guests are in virtual machines or in containers. Okay. In addition to providing integrity assurance, Cloud Integrity Technology also gives you the ability to provide you a trusted geolocation information. So today in the current generation, the geolocation is manually entered into every server at boot time, and then from there on, you make that visible in a trusted way to orchestration and compliance tools. One of the interesting work that was done with NIST by Intel and a couple of other security companies is the release of a publication called IR 7904. IR stands for Interagency Report. This is a report that talks about the need for trust in the cloud and the need for trusted geolocation in the cloud so that you can meet the compliance requirements for boundary control in variety of business segments. One example is the GXP, like Heather was talking about, where there is an explicit requirement of boundary control. The other example is FISMA, the whole Federal Information Systems Management Architecture, which explicitly again talks about controlling where the workloads can or cannot run in a multi-availability zone cloud environments. Okay, a variety of these compliance requirements for boundary, for integrity assurance can be enabled by what Intel provides through TXT and CIT, and Cloud Raxak is a compliance environment that leverages these capabilities to provide you that hardware assurance. Okay, I think one of the things Sesh is going to follow on here is actually show you a demo of how these two or three technologies come together and provide you that ability to provide compliance. So Sesh, take it away from here.
Thank you. Thank you, Raghu. So I'm going to show you a quick demo of how the Cloud Raxak is going to secure a OpenStack running on top of bare metal servers, all the way from using the information coming in from CIT all the way to the guest VMs. So the first, in step one, this is what I'm going to show you and I'll tell you very briefly. We query the Intel CIT servers to make sure that the machine booted correctly. Next, we ensure that the operating system is configured correctly based on information coming in from the outside that's hardening the OS. Next, we go in and harden OpenStack. That is, we check the executables and the settings. And lastly, the guest VMs are automatically enrolled inside Cloud Raxak, and when they are created, we apply the PCI DSS profile, which is a stand-in for the profile that the customer wishes to apply. So let me, without further ado, jump to the demo. So first, we're going to show you the process of applying the boot compliance to the machine on which OpenStack is running. That's NUC1. You can see NUC1 is already enrolled in Raxak Protect. We will apply the OpenStack controller profile, a security profile that uses the TXT and TPM chips and CIT to verify the boot files and the kernel of NUC1, the OpenStack controller node. In actual operation, this profile would be applied automatically, but we're going to show you this manually so that you can see the steps. So we apply the profile manually, like I said, and the Success tab shows you that this particular profile was applied successfully. Let's next go to the console log to see what actual steps were applied. So we can see that the TXT measured launch was executed in the machine. That is, when the machine was booted, it tested the BIOS, the kernel, and these measurements were stored in the immutable log in the TPM, the chip that holds this data securely. As we scroll through the log, we can see that we have a trust agent running on the platform, and the trust agent validates the measurements that were made, and then reports this back to the CIT server. The CIT server holds the signed signatures of these measurements. We retrieve this data from the CIT server. It returns all of the trust measurements that were made in a signed format where the signature can be signed and attested and checked to be that of the Intel hardware. Further, as part of these measurements, it returns the geo tags associated with the hardware, and in this case, you can see that we verify the country, state, and the location of the server. This enables you not just to verify that it booted correctly, but to ensure that you run only on trusted servers. This is a key aspect of what Raxak Protect can enable using the CIT technology. We have now verified that the machine booted correctly. We're now going to, and that the kernel is secure and trustworthy. We are going to use this kernel to verify the settings of the operating system to lock it down with the mission critical classified profile. So the DISA mission critical classified profile is one of the most stringent security profiles available. It has a variety of rules, about 250 plus. For example, root 38443 says that etc. G shadow file must be owned by root. Other examples include that all the hashes of executables must be checked against RPM, for example. We can explore a particular rule by checking what it says. Raxak Protect shows you what the rule asks for, and if there's a violation, how to fix that. We are going to apply this profile the mission critical classified profile to NUC1, the bare metal machine that will run OpenStack. We choose manual remediation and start the process. Once it's completed, we can see that a number of rules executed successfully. But if you go to the failure tab, you will see that a number of these rules from the DISA STIGS did not execute successfully. For example, the rule that etc. password must be group owned by root was not executed successfully. We can, as I mentioned, we can take individual rules and remediate them. In this case, we're going to take this particular rule that it needs to be group owned by root and remediate it, pressing the remediate button. Once you do that, the Raxak Protect fixes this in the background, and you can see in the Success tab that it is marked as running successfully. We have shown you how we were able to lock down the operating system and using individual rules. Next, I'll show you how you can automatically remediate all of the rules that are present in the DISA STIGS. So again, you pick Nuke 1, you apply the DISA Mission Critical Classified Profile, and you remediate using automatic remediation. And once this is completed, you will see in the Success tab that a number of rules are executed successfully, and that the remainder were remediated used by Raxak Protect. So we have finished talking to you about how the Raxak Protect is able to lock down the operating system. Next, we will show you how we lock down the guest OS. I'm going to speed through this so that we can get to your questions. So as you can see, these machines have been automatically enrolled inside Raxak Protect. We apply the PCI DSS profile for the guest OS to CentOS guest, which was already enrolled. And once we apply it, we find that a large number of rules were not executed successfully. That means that the machine is not in compliance with the PCI profile. We then go in and we apply this profile automatically, and once that compliance checking is done, we find that all of the rules that failed initially were completed. So we have shown you how Raxak Protect is able to use a hardware root of trust to go all the way from the hardware up to the guest OS and protect the information out there. So to summarize, what we have shown you is that the Raxak Protect is able to provide security compliance from boot to end of life and on both public and private clouds. It enables customers to apply identical security profiles to protect these cloud assets. Lastly, we showed you how an industry-first capability to provide assured compliance based on a hardware root of trust that's available on private clouds and on soft layer. In these cases, on private clouds and soft layer, Raxak Protect takes the boot time information provided by CIT and extends it all the way to the guest VMs to provide assured compliance from boot to end of life. Thank you. So we'll now get to your questions and the poll results.
Thanks, Sesh and Heather and Raghu for presenting. So we'd like to go quickly through the questions. We have one question, and please post some questions if you have them. we have one for Heather. It said we should argue for the creation of GXP or good computing practices or good compliance practices similar to the GXP in the life sciences space. So any thoughts on establishing good computing practices as a new GXP?
I think that that's a brilliant idea. I would love that. Would provide a lot of, I think, stability and remove a lot of the angst as to how cloud environments are managed. I'm going to take that and see what we can do with it internally with some of the groups that we've got. And if the person asking the question wants to reach out to me, you know, separately, hinton@us.ibm.com, I'd love to talk to them and see how we could collaborate to bring something like that into effect.
Great. Thanks, Heather. Another question, how do we ensure data protection in Cloud Raxak? Sesh, you want to take that one?
So the data it has to be protected at rest and in motion. And you do that by encrypting the data that's coming in using TLS, and the data at rest you can encrypt using a variety of programs. Raxak Protect checks to see that this encryption is in place, and if it's not, it calls this out as a compliance finding, which can then be remediated. There is another question that came in, which is that whether Raxak Protect can handle not just OpenStack, but containers also. So the answer is yes. I showed you a demonstration of how we can take the hardware root of trust and go up through OpenStack. Exactly the same thing can be done for containers. You can verify that the container is secure, and then that the settings for the OS on which the container is running are secure up the stack. So there are a number of settings there, and if the person who asked the question would reach out to me, I'll be glad to take you through that in detail. Back to you, Russ.
All right, thanks, Sesh. I think that's all the questions we have time for. Just a few more minutes left. Remember, look at the attachments. There's a downloadable guide to security compliance and also a link to the website for additional resources, including other webinars, videos, presentations from IBM that you can take a look at. So I'm just going to add another quick poll here to sort of wrap up the conversation. And those, we had some random audio issues, I think, from people in the audience. We didn't hear that, but just in case there are, the actual presentation will be cleaned up a bit. So if you want to come back and look at it later, if there's pieces that you missed for whatever reason because of your audio connection, you'll be able to hear it in crisp, clear fidelity as a follow-up on demand. So this will be available on demand for you to view later. So let's go ahead and do another poll. And we're going to, since you've now learned a little bit about security compliance solutions, I'll ask you a couple questions about what you're doing around your security compliance posture across all your different areas that you're competing today around traditional IT, private cloud, and public cloud. So let's take a quick vote on that and let us know what you're doing today. Looks like we have a couple more questions come in, so if we have time once we finish the polls, please get your votes in. All right, we've got some good poll results for that. So let me, just a few more minutes on that, and we'll jump to the last question. Okay, let me see if I can just look at the questions real quick around firewalls. There's a question around, does your solution apply settings on the fly? Is it required to reboot a server right after configuration is applied? Sesh, you want to answer that question?
So it does not reboot the server in all instances. Certain settings require that server be rebooted in order to fix them. That we typically create a ticket that's done by the sysadmin under a change control. So we do not go and reboot the server for remediation. There was another question here. Okay, that's it.
Hey, Russ, can you go on mute while Sesh is talking, please?
Yeah, so let's go ahead and wrap up. So thank everybody for attending the webinar. Again, if you have any additional questions, please submit them and go to www.cloudraxak.com, visit the resources page, or send an email to info@cloudraxak.com. And please view the webinar again on demand in this location. Thank you very much.